So on the last tide video, we talked about what are tides and what causes them. You typically have 2 high tides and 2 low tides in a day. The tides come 50 minutes later each day because the moon is also going around the earth. Throughout the month, you're going to have stronger or weaker tides called spring or neap tides, which will change the range and also the maximum and the minimum for the tides. Now, what I want to talk about in this video is how tides get complicated, or in other words, how it's not as simple as we talked about in the last video, either the causes or the variations. When you actually study tidal fluctuations, you will see that, you see in here in this picture, you might not understand what the picture is trying to show you, but the different colors are actually showing you different tidal effects in a specific island or region. And you can see that one island, different parts of the island are actually experiencing different kinds of tides. And so what kind of sense does that make? It's all in the same part of the ocean. Why would you be experiencing different tides? Look here on the Nova Scotia, and you can see how the high tide raises the water by 46 feet up here, 49 feet up there, but up there is only 20 feet. So there's something's going on there that's causing the tides to be different. And just by looking at the picture, you should be having some sort of a guess at what's causing the difference. Also, look at here. Some places see 1 high tide, 1 low tide per day. So you have a high tide, 12 hours later you have a low tide, 12 hours later you have a high tide. That's not unusually happens. When we talk about 2 high tides and 2 low tides a day, the normal is supposed to be the semi-diurnal tide, which sees a high tide, 6 hours later a low tide, 6 hours later a high tide, 6 hours later a high low tide, and so forth. Not exactly 6 hours though, because the moon is moving at the same time. Remember we talked about that. Some places see something like the semi-diurnal tide, except that one tide is lower than the other. Or one high tide is also higher than the other. What's going on here? Why is there so much change between the way the tides work? The simple answer is that how much tides actually work depends on the size of the basin that you're talking about. So for example, something like the size of the Pacific Ocean will barely experience tides because you have extremely ginormous ocean to actually move by gravity. That's a lot of matter to drag and create a boat with. Meanwhile, if you have a small basin, say like a bay, a tiny little bay, that might actually magnify the effect of the tides. You see what I'm saying? The depth, same thing. If you're talking about a very deep ocean basin, it's going to be harder to cause the tide to happen. Again, Pacific Ocean, less tides because of that, right? But you're going to have more tides on the Indian Ocean because it's smaller and also have less depth. Also, location will also make a difference. If you have a narrow path or a canal between 2 tide places, so for example, you see here narrow canal or inlet between New Brunswick and Nova Scotia, you actually, as it gets narrower and narrower, the tides get more and more pronounced, right? So you can see how you're going to have these effects. You might actually have only 1 or 2 tides a day because it's going to deflect the tidal wave motions and things like that. So now we raise the problem here. I thought tides were caused by bulges from the sun and the moon moving around and pulling the earth plane. How come you get these variations then? That doesn't make any sense. If there's a bulge, there's a bulge. If it's twice a day, it's twice a day. If there's 2 bulges, it's twice a day. It doesn't make sense to be only once a day for one place, but the other place that's really nearby has only once a day. That doesn't make sense. Over there, you have 1 tide a day. Over here, you have 2 tides a day. How does that make any sense? It's in the same place. The boat should affect both the same. What's going on? Also, think about the speed here. If you were technically getting the ocean and dragging it from the place that's stretched to the place that's bulged, all in one day, you have to move this massive amount of water from one place to the other part of the world. How can that possibly happen in 6 hours? It's not going to happen in 6 hours. Also, if you're getting a tide where the water's basically creating a wave, it's a slow wave, but it's a wave that's coming and hitting the continent, shouldn't that create a reflection that causes another wave to go the opposite direction and erase the tides on another continent on the opposite side of the basin? So for example, if a tide is being created up here, shouldn't that create a reflection effect that actually cancels out the tide on the opposite side? But if the same is taking us through backwards, so there should be no tides. That makes no sense, right? how come one place has more tides than the other? How come one place has faster tides than the other? How come some places have higher tides than other places if the bulge is the same for everybody? How come some places get the tides after they're supposed to get it? The bulge is gone, the tide is coming. That happens sometimes too. And how come you have the bulge on the opposite side caused by inertia? What? No. None of this makes sense, which tells us that the classic explanation for how tides happen is not a complete explanation. Now, it might be good enough for most cases, but just like Newton physics is not enough, and you need Einstein relativity to explain things, and nowadays not even that is enough, there's a better explanation to explain what happens with tides. And we call that gravity wave nodes. Well, I know, it's really complicated, but here you have what I'm talking about. You can see what actually causes the tides. Now, you see that what causes the tides is that as the moon is going around the earth, it's causing the oceans to spin, literally to spin. It's creating these gravity waves, very long tidal waves. We call them transtidal waves, which are basically rotating around the ocean from one central location, creating these tidal effects, right? Now, certain areas will experience higher tides because of the way the circulation is happening on that area. Other areas experience less tides because the circulation will happen less if you have a deeper basin, a larger ocean, and so forth. So look at the deepest parts of the Pacific Ocean, you have less tides. But whenever you have a continental blockage, which causes the circulation to speed up, you're going to have more tides. So you can see the difference in tidal effects and how tides would actually take. Now, why is it that you have to seem to get this daily cycle? Because all of these tidal waves would typically, if unobstructed by the shape of the continents or by the depth or by the location, it would take 24 hours for each one of these nodes or tidal nodes to rise or fall. So look at what happens here. You have a node, which is a knot, a gravitational knot, and then you have the anti-knots on the other side over here, and then water is circulating from node to anti-node and backwards, and if there is no obstruction, because it takes 24 hours for the moon to go around, it would take 24 hours for this wave to go around, for this current to go around. Alright? Now, if you have a deep ocean basin, or if you have a very large ocean, or if you ever have a very narrow basin, all of these things will disrupt the rotation of the tidal gravity wave, and then therefore change the way the tide happens in that area. More complex, maybe you don't understand, it's okay. But you need to understand this much. Our current understanding of tides is that tides are not caused just by gravity versus inertia. Tides are caused because as the moon, look at my hands now, as the moon travels around the earth, it drags the oceans with them, but not completely with them. It's not like, you know, the moon is here, you have a bulge here, and as the moon moves, the bulge moves with it. No. You move the ocean a little bit as you move around. And as you move around, you move it less and less. In other words, when you're on the opposite side, on the side corner here, so let's go back to the hat. When I am facing the front of the hat, the moon is moving this water more. But when it's on the side, it's no longer moving the front of the hat as much. And so this will create a circulating pattern. Now it moves a lot, now it doesn't move so much. And then we'll create a wave that circulates around the basin as the moon circulates around the earth. And then depending on the basin, the shape, the depth, it would change how long it takes for actually each circulation to take place. Which is why sometimes it's 6 hours in between, sometimes it's 12 hours in between, sometimes it's a whole day in between, sometimes it's not synced with the passage of the moon, sometimes it's a lot higher than other times, sometimes some places have higher tides than other places, all because there's different kinds of wave generated in different basins. So it all now makes sense and why you wouldn't experience a lot of tides. By the way, notice that the Gulf of Mexico barely experiences tides, and so Florida doesn't have very high tides because of that. Alright? Now, another idea that we have to talk about, again, remember the idea of the tidal node and how it creates waves because every time the moon goes by, it creates this node that has to rotate around from node to anti-node and backwards in 24 hours or less, depending on the shape of the situation, right? Now, because this is a wave we're talking about, you actually have a fluctuating tidal pattern. That over a period of a month, you might have higher tides some days than others. And so then throughout the day, you actually have oscillations of the ocean water, or little waves created by tidal motion. And those are called tidal oscillations, or the movement back and forth of the water because of the tidal nodes which are moving around. Okay? Now, these tidal oscillations will be bigger in seas than they will be in oceans. So let's go back and look at that. Look at the picture of the tide around the world. Look how the seas may sometimes have larger tides than the other areas. Okay? All depends on the depth of the sea and things like that. Also, usually tides are stronger near the shoreline than away from it. You can definitely see this here in the pictures. In the deep ocean basins where the water is really deep, you're going to have less rotation of that node going around. Also, like we talked about before, there's going to be a bigger oscillation along a narrow bay or a narrow canal, like you see here in this inlet, which is connecting a bay to the open ocean. There's going to be a lot of variation across this inlet, more than you would have if you didn't have that. Okay, so there's going to be bigger tides happening along the canal, but maybe lower tides inside the actual harbor. So that will all mess up with things. So tidal oscillations, or the waves caused by tides, change depending on if it's a sea or an ocean. Deep ocean basins have less tides than shallow seas, and the shoreline has more tides than open oceans. And you see more tidal waves in narrow bays and canals than you see in open water as well. Now, because you have these tides moving back and forth and these waves rotating around the ocean basins, you actually have currents associated with waves, the same way you have the breaker current, the undertow, and so forth. Whenever the tide is heading towards the land, or it's time to flood the land, we call that a flood water. So flood waters will tend to happen when the water is actually trying to flood the land. So during high tides, the water is going towards the land, right? During the low tide, the water is going to be going away from the land, right? Now, that is called the ebb water, or the receding water. In between the high tide and the low tide, you have what's called the slack water, when you don't really feel a current caused by tides. Now, you feel more of a current if you're closer to land, or if you have a stronger tide. So that means the same variations which change the oscillations and the intensity of the tides will also change the intensity of these currents. So an area that sees extremely high tides will have stronger flood currents and stronger ebb water as well. Okay, so it's called flood water versus ebb water versus slack water. Also, why are tides important? It's something you need to know. Remember the intertidal zone. Intertidal zone is the area of the ocean that's sometimes above tide, sometimes below tide. That whole ecosystem is based on tides. So that's definitely important for the life of the intertidal zone. Also, when the tides coming in and out, they carry nutrient. The ebb water, which carries water away from the continents, takes nutrients from the continents to the open water. Meanwhile, the flood water brings stuff back from the oceans towards the land, which actually helps recycle nutrients to and from the open water and the continental shelf. The same thing is true about plankton. Remember, plankton is the tiny little life forms which are the basics of the food chain. Most of the plankton tends to concentrate near the continental shelf, where waters are shallow and have a lot of nutrients. But during the ebb water, some of the plankton gets picked up and thrown to the outside. Just like it's better to launch a boat during the ebb water when the tide is receding, so it's easier to launch the boat. So this plankton also gets taken out to the open ocean because of this ebb water. So tides are definitely important in the formation of marine life. It's also important in the formation of dunes and berms. Berms, like I told you before, are these mounts of sand that form in the beach. That's gonna form because that's as high as the high tide goes. And so every time a high tide comes through, it will push the berm further into the beach, creating that mount of sand near the beach. Also, when the low tide comes, it exposes more sand to be dried out by the sunlight, which then gets picked up by the wind to make dunes. So dune and berm formation, in other words, dry beach formation or backshore formation, has everything to do with tides as well. Tides, or the ebb water, is also what takes some of the sand from the beach to the lower waters of the ocean. So tides have everything to do with the formation of the shoreline as well, which we talked about in a different lecture series. So tides are definitely important for the ocean, and I hope these 2 videos were enough to clarify what they're all about. And we have one last video to talk about with the movements of the ocean and to finish off the topic. See you guys there.